Okay, our objective is to talk about combinations today, which is when order matters and when it doesn't. So that's what today's for, to really talk in more detail about that. Well, how do we know? Okay, we're going to go through a lot of example problems in the notes and then as well as your homework assignment today to get you to think about that. Okay, when does it matter and when doesn't it? So the first warm-up was page 5 in your notes. Just the top of it, bless you. You had to list how many ways you can arrange 2 of the 4 letters they gave you. So the first thing you should have done, kind of like we did yesterday, is have AB, AC, AD, okay, BA, BD, BC. It doesn't have to be in this order. CA, CB, CD, and then DA, DB, DC, okay? So once you do all that, they first ask you, how many permutations are there? So, Mary, how many permutations are there? Good. There's 12 permutations from that list. Why are there 12 permutations? Why? Emma H? Good. Order mattered. So again, if you came into class and I said, all right, what's the password? If it was AB, but you told me BA, that's a big difference. So with permutations, the order matters. These 2 arrangements are very different. The second step tells you this time, cross off any arrangements that are repeated. So what are some things we can cross off? Justin? Good. What else, Justin? Good. Okay, someone else. What else can we cross off? Briar? Okay. What else, Briar? Give me one more.
About the person in your life with the greatest smile. How do you feel when that person smiles at you? Do you feel good just thinking?
Can you find another one? There's a couple more. I just didn't want you to give me one more. Okay, CB. Adam, what else? Okay. Adam, what else? Okay, perfect. All right, so I think we've crossed them all off. So we crossed off all the duplicates. In other words, A, B, and BA are the same thing because they have the same letters. Okay, so these are a repeat. BD and DB, wherever it is, these 2, sorry, are the exact same thing. So we crossed one of them off because it's a repeat. Same letters, just different order. How many combinations are there with us crossing that off? Melissa, how many combinations are there? There's 6 combinations because we're going to talk about today. Order doesn't matter with a combination. So if you came in, I was like, all right, just give me the letters you need to get into class today. If you told me A, B, or BA, same thing. Okay? Doesn't matter. Order does not matter. Annalise? That does not matter at all. Nope, same thing. So hopefully you guys all have 6 combinations here. That's what's important. Any questions, Matt? That's fine. That's because you're ahead of where we are. That's fine. Any other questions or comments on that? All right, so let's, Jeremy. No. No, it's not half of it. Nope. In this one it is, but not always. Okay. All right, let's go to the other warm-up, okay, which was in your homework packet on page 9, 1 through 6. So I think we need to have more of a discussion on these ones. Now, of course, today's lesson will take care of a lot of these as well. Okay, so 1 and 2 on page 9, these ones, I know made some of you guys think. You had to determine whether it's a permutation or combination. So what do you think? Page 9, what do you think about number 1? Is that a permutation or combination? Briar, what do you think? Why do you think it's a combination? Okay. Anyone else have an opinion either way, Matt? Okay. Why? Okay. Charles, what do you think? Okay. Okay. Emma H? Okay. Anyone else? Opinion either way? That's okay. I can't do it in class. And don't forget about your other thing. You didn't come see me. Do you have it here or no?
Yeah, I have it.
Can you just leave it here? I'll give it back to you in class.
I need to take it down there now.
Is that, did you look up your grade?
That's what you said.
Yeah, yeah.
Thank you.
You're welcome. Okay, so number one is a permutation. Okay, I'm just going to put a P here. So here's why. Okay, how many different ways can 20 students line up for an assembly? Anytime you get in line for something, the order's going to matter. Now, I know to some of you, you're pretty laid back and it doesn't matter to you, but think about when we go out for the buses. I always tell you guys not to run. Why do I say that? You guys always want to do what? Mary? Yeah, get in a different order. And also, you guys all want to be in the back of the bus because you like to fly out of your seat when you go over the speed bump. So, what? That's not really why. Okay, well, whatever. In my mind, that's why, right? So, some of you like to be in line first because you want to get to the back seat. When I was in college, when Penn State would go to one of the bowl games, we would get in line to get tickets. And sometimes they would do it that whoever was in line first got a better ticket. Sometimes they would do it based on a lottery system. But if they did it one year based on whoever's in line first gets a better ticket than someone that's in line 10th, well, we wanted to be in line first because we wanted to go to the bowl game to watch Penn State play. So there are many times when being in a line, the order is going to matter. One of the key words for permutation is line. When you're in line, order matters. Okay? Now, again, I know to some of you, you're like, oh, I don't really care about that. You know, I don't care where I am in a line. Well, to a lot of people, it does. If you're just getting in a line to go to another class, it shouldn't matter because you're just getting in line to go to class. Now, some of you might be thinking, well, I want to sit in the back of the class, or I want to sit here. So again, you're going to have personal preferences as to where you want to be in line and for your own reasons. So the word line in math is always going to mean a permutation. Emma H? Okay. Yeah. I won't do that. Mary? Say that again? Yeah. Then you'll want to be. Yeah. So, yeah. Okay, so number two, how many ways can a teacher choose 2 students from her class of 15 to distribute flyers to other classrooms? So what do you guys think about this one? Annalise? Okay, what's your reasoning? Okay. Okay. Adam, what's your reasoning? Okay, what's your reasoning? Yeah. Okay, you're right. It's a combination because I'm going to pick 2 people. What the problem is saying is that the 2 people that I choose to distribute flyers, it doesn't matter the order I pick them. They're still going to both distribute flyers, okay? Or they're still going to both carry that big present to the library, okay? Whatever the task might be, I'm picking 2 people. The order that they do something doesn't matter because they're both going to contribute or they're both going to help. This kind of means the word group. Anything that is associated with the word group is a combination because the order they're placed in that group or the order that they do something doesn't matter. We're going to discuss more of this today, and I'm going to give you a list of keywords. All right, Zach, what'd you put for 3? Awesome. Sean, number 4. Good job. Emma M, number 5. Oh. Okay, how about 6? Good, 720. Who would like to help us with 5? Mary? Good, 650. Number 5 was a permutation of 26 letters, excuse me, chosen 2 at a time. So number 5, there was a 2-digit code, and it was a letter code. So they asked you how many codes are possible if the same letter cannot be used twice. So order matters. It's a permutation of 26 letters. You're choosing 2. Okay, questions? Annalise? So it's 26 times 25 is the multiplication counting principle. That's the same thing as this formula. Permutation means order matters. Remember the formula from yesterday. 26 factorial over 26 minus 2 factorial, which is 26 factorial over 24 factorial. So dividing all this is the same thing as taking 26 times 25. So you're exactly right, but it means the exact same thing. Yeah. In that pink folder back there, it's sticking up. Do you see those folders? Annalise, does that make sense or no? No, 26 factorial over 25 factorial is the same thing as 26. So 26 times 25 is the same thing as 26 factorial over 24 factorial. Think of all of them being listed out like we did a couple lessons ago. Okay? So Annalise, you don't really need to remember all that. You just need to know the order matters. The letters can't be repeated, so it's a permutation. 26 letters, you're choosing 2. This formula takes care of the repeats. Okay, remember, just like we crossed them all off with the combination thing, this one takes care of the repeats. Sean? That's what I just told. It's the same thing. Multiplication counting principle and this formula are going to be the same thing with problems like that. Okay, anyone else? Is everyone clear on 5? You guys all right? Justin, you okay? If it's what? Yes. Good question. All right, let's go over homework. I need to find mine, and then we'll go back to the notes. So 13.2. Okay, we're just going to go around the room here. We'll see how you guys did. We'll come back to questions. Okay, Doug, we'll start with you on 13. Wait, hold on, I'm on the wrong page. Okay, good. 120. Alyssa, 14. Good. 15, Justin. Good. Charles, 16. Good job. Jeremy, number 17. Good. Number 18, Donatus. Good. Emma H, number 19. Good. Greater than. Mary, number 20. Good. Adam, 21. Good. Emma M, 22. Good. Zach, 23. Good. Briar, 24. Good. Sean, 25. That's okay. 720. Annalise, 26. Good job. And Justin, 28. Awesome. 1 over 720. All right. Questions? Very good job. Mary? Wait, put your hand down. Were they the same problem or similar? Okay, sorry. Sorry, my fault. Sorry. All right, so then I guess there's no questions. No, your homework's not like this today. Wait, hold on. Shh, hand up. Sean? No, it'll be harder. It's harder. Mary? No. Sorry. Okay, shh, guys, questions on this? All right, take out your notes. We're going to go back to combination, so back to page 5 of your notes. Okay, starting with the, little bit down where that box is. Okay, we're going to start with combination. What is it? Okay, so combination is an arrangement of objects in which order is not important. So can you guys think of an example in life in which order does not matter besides the stuff we've already talked about? So when would order not matter? Charles? Yep. Okay, good. Order how you bring those two doesn't matter, is what you're saying, right? Exactly. They're all pencils. Even though they're different colors, you're bringing those two to school. Order doesn't matter. Now, if you're like the 9th graders, they lose their pencils constantly. I know some of you guys do too. But then, okay, that might be annoying because they might lose them. But if you're bringing them to school, shouldn't matter. Mary? job. Very good job. If they're all getting the same prize and they know they're getting it, the order that you select them to get that prize doesn't matter. That's what you're saying, right? Perfect. Did you think of that on your own, or did you see that somewhere? Good job. Very good. Annalise. Yep. Good. And you could also use that from the analogy of, or the aspect of it, the way you put them in your cart doesn't matter because you're getting all of them. You know, you're choosing the ones you want. Emma H? Oh, yeah. Yeah. Exactly. Good. Justin. Uh-huh. Good. And that was one of my examples. And that kind of reminds me, the order that you put food on a plate, or that your parents put food on a plate for you, the order that you have it on the plate doesn't matter, kind of like your buffet example, because you can turn that plate and you can eat it whichever way you want. Now, if it bothers you that your food touches, that's a different story. But the order that it's on the plate doesn't matter, because you can flip it around. You can eat your french fries first, or you can eat your peas first, okay? Whatever's on your plate. Emma M? Yes, unless it bothers you that, like, you want to get there the quickest way. So, but I understand what you're saying. You're still, if the point is to get to a certain location, it doesn't matter then, because they're all taking you to the same place. Okay, let's do one more. Charles? Oh, big time. Yeah. Yeah, you can't bake it without mixing the ingredients together. Okay. Was that your point to that? Okay. All right. Let's hold off on these other ones for till later. So it's funny. I actually have the example up that Mary gave. The example I have up here is drawing identical prizes. If I told all of you that you won $1,000,000 today, and I brought in $1,000,000 for all of you, the or the order the order that you selected, that identical prize that I brought in, doesn't matter. Kind of like when I bring cookies in. As long as they're all the same, the order that you get it doesn't matter, because you're all getting one. Okay? I said if they're all the exact same, Matt. So drawing identical prizes, order doesn't matter. The way you have food arranged on your plate doesn't matter. Kind of like the buffet example. You guys gave awesome examples. So the notation is NCR. The order doesn't matter. N is the number of objects. R is the number of objects chosen at a time. So just like the N and the R mean the same thing as permutation, okay, it's just a C instead of a P, which I know you guys pretty much all figured that out yesterday. Next to or underneath that, I want you to write down the formula. Okay, combination order doesn't matter. So the formula to NCR is N factorial over N minus R factorial, okay, to get rid of the ones that we're not using, and then times R factorial, because a combination order doesn't matter. So you have to divide by that R factorial, because order doesn't matter. You do not have to memorize this, okay? You may use it from the calculator part. The biggest thing you need to remember is that permutation order matters, combination it does not matter. I'm giving you the formulas because I know some of you are curious to see how it works with the calculator. You don't have to memorize that. The calculator steps, okay, so if you write down next to that, our math prob number 3. Don't do it yet because I need to show you how to get, well, you probably know, but we're going to go through this together. Math prob number 3. What, Jeremy? N minus R factorial times R factorial. Annalise? Because the order doesn't matter. So the N minus the R is the same reason for the permutation. You're dividing by the ones that you don't use, times that R factorial, the ones that we are using, you're dividing by any repeats. Think about the letter arrangements. Okay, you're dividing by the repeats because it doesn't matter in this case. Okay, A, B, and BA are the same thing. So that's why you're dividing by that r factorial. Because think about how we found letter arrangements. Anytime you find how many ways there are to arrange anything, it's multiplication. It's the multiplication counting principle. That's why we started with all that. It's never adding or subtracting. When we get to compound events, you're not arranging things. We're going to get to that tomorrow. That's when you add and subtract. So maybe that'll make more sense to you when we see different probability. When you're arranging things, the number of ways there are to arrange them, you have to use the multiplication counting principle. This is part of that, but the combination and permutation formulas make it easier for you guys to solve them, okay? And Annalise, you don't have to know this. This is just for those that are interested in understanding why. We're going to use it on the calculator, okay? Mary? Yep. Cool. Very cool. You can do it either way, and that's what Annalise was asking. Like, it's still the same thing as making tree diagrams or listing them all out. And I know Charles got in trouble for that in elementary school, that he used the formula instead of listing them out on a test or whatever. I'd rather you apply the formula because I want you to be efficient at solving your math problems. Yes, understand them, what you're doing, but to be efficient. So Mary, either way, whatever you prefer, that's a lot of choices to write out though, right? Okay. You told me you got 28. Yeah, you're good. Or I shouldn't say you told me. I assumed you got that. Okay, so let's revisit the warm-up, okay? So using a combination for the warm-up, we have 4 combination, choose 2. Okay, so let me go over to my calculator just to make sure you guys are all with me on that. So to use the combination formula on the calculator, which is the way that you can do it, you don't have to do it by hand, is type in 4, go to math, PRB, number 3, hit enter, type in 2, hit enter, make sure you guys all got 6. So just like yesterday, but we're going to number 3. Alyssa? Say that again? Good. Very good. Emma H? Good. All right, that's okay. Wow, you guys, I should have just had you do the whole page as the warm-up, right? Okay, so if you prefer to use the formula, you would have done 4 factorial over 4 minus 2 factorial times 2 factorial. So we have 4 factorial over, you're dividing by the ones you aren't using, which is the 2 factorial, times you're dividing by 2 factorial again to get those repeats out of there. Order doesn't matter in a combination, so you have to divide by the number of repeats, which it's always going to be r factorial because that's how many objects that you're using to arrange. Okay? So regardless of the way you do it, you're going to get 6 either way. When I learned it in high school, they made us memorize and use the formula, but since you guys have these nice calculators, I say use this way. With the understanding that you know combination order doesn't matter, permutation it does. Okay. Doug. No. 2 factorial times 2 factorial is 4. 4 factorial is 24. So no. Very different. Any other questions? Okay, so let's do these examples. And I'm not going to go through the calculator anymore. You guys can do that part on your own. All right, who wants to read example 1 for us? Go ahead, Sean. Okay, why does order not matter? Why is this a combination? Annalise, why is this a combination? Yes, you can kind of turn your plate. Like I like to eat my salad first sometimes, so I can like turn it or move the bowl to the front. The order you have that on there doesn't matter. It's still your food. No one's taking it from you. Doesn't have to be touching. Okay, Charles? No, no, no. We're not worrying about those. Okay. Oh, because you don't like it? And you want your dog to eat it? Okay, well, we're not going to put a dog into this equation. Yes, you may. Okay, so 8 sides side dishes. We're choosing 2. Type that into your calculator. How many combinations of side dishes do you have to choose from? So now you can do this when you go out to dinner. Briar? Good. 28 options of side dishes that you have to choose from. Okay, so now you can ask your parents. See if they can figure that out when you're at dinner next time. If there's 8 side dishes or however many there are, well, how many options do you have for choosing 2 or 3? Okay, you can make them think. Sean? Wait, say that again. So, yes. I would not make a tree diagram for something like this because it gets too confusing. Since there's 8 and you're choosing 2, it's going to be completely long and confusing. Kind of like that one we did with the cards, if there's 6 and 4, but you're choosing 2. So I would stay away from tree diagrams unless you're choosing the same amount that you have. Okay? Do you like tree diagrams better than this, or you're just curious? Yeah, I would stay away from that on these problems. Adam? Yeah. I know. That's why I told you to hit number 3. When I gave you this, no, press number 3. No, I always press it. But thank you for saying that. Yeah, I don't like scrolling down. Not that I'm lazy about that, but it's just easier to hit 3 or hit 2. Completely. All right, Matt's lazy. All right, number 2. So a local movie store is having a sale. Buy 2 movies and get 1 free. The sale is only good on a list of 10 movies from the store. How many combinations of movies can you buy? What's the setup here? So let me first ask you that. Alyssa, what's the setup? Nope. Close though. This one's tricky. Go ahead. Good. Why 3, Alyssa? Good. You buy 2, you get 1 free. So you're walking out of that store 3 movies. Buy 2, get 1 free. You have to read carefully. You're not just getting 2, you're getting 3. Why does order not matter on a problem like this? Emma H., why does order not matter? Yeah, you're taking them home with you, right? You're getting 3 movies. The order that you take them with you, or the order that you take them up to the counter, or the order that you pick them doesn't matter. You're still getting 3 movies. Okay, you can watch them in whatever order you want when you get home. Matt? Yes, because it's buy 2, get 1 free. So based on this problem, they're the exact same price. Good point. Annalise? It tells you. You're buying 2 movies, and you get 1 free. Okay? So how many ways are there to choose out of 10 movies to choose 3? We know it's buy 2, get 1 free. Zach? Good. There's 120 combinations of those 3 movies. Okay, order doesn't matter. There's 10, you're choosing 3. All right, 3. 4 students from your class of 120 will be selected to organize a fundraiser. How many groups of 4 students are possible? So what's the setup of this? I want to start with the setup. Jeremy, how do we set this up? Good. So 120 students, you're choosing groups of 4. Why does order not matter on this? Why does order not matter, Emma M? Good. No matter what, there's 4 students in a group. The way you organize them in a group or place them in a group doesn't matter because there's going to be 4 students in a group. So the order, how they're arranged in that group does not matter. They still have to work together. Sean? Sure. Okay, how many combinations of 120 students of 4 groups, Justin, are possible? Good job. Annalise. No, because it's saying once you have those groups of 4 people, the way you organize them in that group doesn't matter. When I pick groups, I strategically pick groups in a certain way, either by grades or behavior or something like that. But what this is saying is when you're in the group of 4, The way you organize them in a group doesn't matter because the groups are already chosen. Anytime you hear the word group, it's always a combination because you're in a group. Doesn't matter how you sit in a group. It doesn't matter how you move around in a group. You're in a group, okay? The teacher already chose it or your coach already chose it, whoever it was. Okay, you're in that group. You're working together. Okay, number 4. Sean, go ahead. Sorry. Mm-hmm. Yeah, no. Because you're finding out how many ways you can arrange them. Yes, because you're figuring out how many combinations of 4 student groups are there if there's 120 students. Typically, you'll see the word arrange on here. I know it's not on this one, but typically it'll be like, how many ways can you arrange them? Or how many different combinations are there? And you'll see that in the homework tonight. They'll use more of those keywords. Annalise? Okay, no. So listen, so before you even do the problem, the groups, you'll kind of already realize like how you're going to pick the groups. So if you already have a plan, this is asking you, once the groups are possible, once you have those 4 people in a group, how many ways can you arrange the 4 people in a group? So if there's 4 people sitting here, the way that you arrange those people doesn't matter. There's already 4 people in a group established. So it doesn't matter how you move them around. Okay, Charles? Yeah, true. Uh, um, Depends on the numbers, but yeah, most of the time. Okay, example 4, to complete an exam, you must answer 8 questions from a list of 10 questions. How many ways can you complete the exam? So there's 10 questions, you have to answer 8. Why is this a combination? Why is this a combination, Briar? Right. If I gave you guys a test and I said, all right, here, 10 questions, pick any 8. Do I care whether you go from backwards to forwards or whether you start from the middle and then go each other direction? No. You can take a test in whatever order you would like, okay? Doesn't matter. Now, as long as I'm only grading 8 of the questions, okay, but it doesn't matter the order that you do this. Doug? Good. Good. So there's 45 different ways to answer questions on a test. If you're answering 8 of them, you're choosing the 8 you want, but there's 10 of them. They still are all going to be answered. Mary? Yep. No, it's not. Right. No. They're definitely not always double. Charles, right. Charles, I think, was saying that combination numbers are typically smaller. Isn't that what you said, Charles? And I agree with him, but it also depends on these numbers. Like, they still could be really big. Yes, they're going to be smaller than a permutation because the order doesn't matter here. Thank you for pointing that out. Charles? Yep. Good. Why? Oh, that's a good point. I like that. Yeah, that's interesting. I like that. Okay, any other questions or comments on that? So combination order doesn't matter. Okay, flip over to page 6. All right, combination versus permutation, the fun stuff. Okay, so now we're really going to have a better discussion on, well, how do we know the difference here? Okay, when do you use which one? Okay, how do we know? Okay, first thing is, I want you guys, we're going to make a list of permutation order matters, combination it doesn't. Underneath permutation, I want you to write the word arrangement. Anytime you see the word arrangement, that means order matters. Anytime you see the word display, which I'm going to explain all these when we get to some problems, order matters. When you see the keyword order, order matters. When you see the keyword places, such as first, second, or third place, like putting someone in order Like if you win first place, you probably get a really big trophy as opposed to winning third place. So anything that talks about teams winning prizes. Okay, what other words? Donatus, do you have another word or? Yeah. Well, you have to use your common sense. These keywords work like 90% of the time. Sean, what's another one? Awesome. Line. We have a couple other ones that we've already talked about. Charles? Good. Ways. I'm not going to put that on there most of the time, but they might even say that sometimes with combination. But that definitely could work. What else? Adam brought this up a couple days ago, the other words that we need to write on here. Emma M? Good. Code. Password. Phone number. Anything like that? Okay, so that's probably a big enough list for permutation. Doug? Okay, wait till we are there next time. Okay, so permutation, we're good there. And again, you'll have more. Okay, use your common sense on some of them. Okay, group. Now, another word that means group is flock, bouquet, etc. So any word that means group, I know you guys are smart and you know what the word group is. Like a bouquet of flowers, no matter how you group them, you're still giving those flowers to someone. You're still getting the flowers. Bouquet gets a little bit tricky because you might say, well, I want them to be in an exact certain order in the bouquet. Okay, so that could be a different story. But for the most part, when you see the word bouquet, it means group. Okay, you're still getting them all. Okay, pairs, the word pairs, and the word blended also means combination. I always think of a smoothie when I think of the word blended. I love smoothies. Yeah. Were you guys all thinking that? I don't know. Math minds think alike. So like when I make smoothies, typically in the summer, and you throw them into the blender, the order you throw them in there doesn't matter because it's getting blended. They're all going to be the same. So I always think of a smoothie there. Milkshake, same thing. Starbucks drinks. The order you put them in doesn't matter with something like that. Those are the only words I have for combination. So again, you want to use your common sense here. Okay, let's do some examples that apply these so we can talk a little more about them. Annalise, question or? Okay, so example 1. There's a litter of 12 puppies. Aw. You're allowed to buy 3 puppies. How many groups of 3 puppies can you purchase? Aw, this makes me want to get a puppy. Okay, did you? What kind? Oh, those are so cute. Oh, did you? Oh no. You didn't get another one? One of my friends has a Labradoodle. They're so cute. Okay. All right, so number 1, C or P? Doug. Good. Why? Good. Groups. Okay. There are 12 puppies. You're choosing 3. It's a combination because the order that you choose those 3 doesn't matter because you're still getting the 3 that you choose. Kind of like the groups in the class. If I'm going to put 4 of you in a group, I'm going to strategically place you. But the way that I put the 4 of you in a group doesn't matter. Just like the puppies. You're going to pick the 3 you like. The way you arrange the 3 doesn't matter. You guys with me on that? So how many ways are there to arrange 3 out of the 12 puppies? Matt? Good, 220. Okay, example 2. Rosario has 5 awards. How many ways can she display 3 of them on her wall? P or C? Zach? Why? Good. Word display is always going to be a permutation. Why, though? Why do you guys think something like this would be a permutation? Mary, why? Yeah, but give me, like, apply that. Right. Right. Sean, you want to add something? You're exactly right. Yep. 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 This always reminds me of my dad and brother live in Florida, but my dad has a room. He's a bonus room in the upstairs of his house, and it's like his Steeler room. He's Steeler stuff everywhere. And he likes to have his Steeler things, whether it's an autograph or a framed jersey, arranged in a certain way. Okay, people want to display things that mean a lot to them, especially awards or autograph things. in a certain way. So that's the other reason why this display is always a permutation. Okay, hands up. Do you guys have an answer or a question? Okay, go ahead. So it looks nicer. Exactly right. Annalise, answer or question? Go ahead. Then it would be a combination, but anytime you see the word display, it's always a permutation. If it's a real life example, that's a different story, but I don't know. I always think of this as most people I would think do care, especially when you're hanging things up in a house. Like, you want them in a certain order so it looks nice. So there's always exceptions, though. Okay, we need the answer. So what is the answer here? How many ways are there to arrange, Alyssa? Good, 60. Okay, let's do the last two, then I'll come back to the rest of your comments. Okay, example 3. Okay, a pizza place offers 3 toppings: olives, pepperoni, and mushrooms. How many 2-topping pizzas can Jack order? C or P? Annalise? Why? Mm-hmm. Exactly. And in my mind, I don't know if you guys agree, but like the order that they put them on there doesn't matter as long as they're evenly spread out. The toppings, not the cheese, the toppings. What'd you say? Not the whole pizza, just the toppings. Because if they made the pizza backwards, I'd be mad. No, just the toppings. So how many ways are there to arrange 3 toppings? Or you have 3 toppings, but you're arranging 2 of them. Emma? Good, 3. Okay, example 4. How many ways can 6 kindergartners line up for recess? P or C? Matt? Good. How do you set this one up? Doug? Good. 6P6 because there are 6 kindergartners, but they're all getting in line. So how many ways are there to arrange all 6 of them, Briar? Good. 720 ways. Order matters, remember, especially if you're in kindergarten. They are going to want to be in the front of the line just because they think it's cool, I'm guessing. I don't know if you guys agree, but I remember that when I was little. We all wanted to be in the front of the line for some unknown reason. Okay, questions. Charles? When you can do 6 factorial. So that's what we talked about yesterday. The factorials and permutations are going to be really similar in a lot of problems. I always do whatever's shorter. Like I would do 6 factorial here. Okay? So whatever, use your common sense. Like I always tell you, whatever you think's easier. Emma H? Yeah. You would think. Yeah. So that could be kind of a different problem. And when you get to something like that, Emma H, do you care about the order? Who knows? Depends, you know? Sean? Okay. Yep. No. Just when order matters. All right. Open up homework packets, page 5. Okay. Hold on. So page 5, you're going to do numbers. Hold on. Hey, guys. Quiet. Numbers 1 through 19. And page 7 in your homework packet. Numbers 1 through 11. Now, page 7, listen carefully. You guys need to determine whether it's a P or a C and then answer it. 13.3 more relates to just combination, so this is going to be easier than this. So 13.3 is page 5 in your homework packet. Page 7 is a worksheet I got from algebra. Well, actually, they're both from algebra. So on page 7, you're going to do 1 through 11. Annalise? Everything we're doing right now is in the algebra packets. Remember I told you our other packets we're pretty much done with. for now. Don't get rid of them yet, though. Yep. Doug? Is this the first what? With the sixth graders? Yes. I am like about 2 or 3 weeks ahead with you guys than I ever have been. And your scores have been great, so it's not like we're moving too fast based on your scores. Some of you may think that, but Jeremy, too slow maybe. Nah, I expect it from you guys. My expectations of you are high. All right, you just be really good at algebra. All right, we're good. You guys hoping for a 2-hour delay tomorrow again? Hey, me too.